Okay, let's take a look at some sum and difference identities. And to start off with, I'm just going to list them out by group. So here's the first two. If you take cosine of the addition of two angles, A and B, that's equivalent to cos A times cos B minus sine A times sine B. And if you find the difference between two angles and take the cosine of that, you get cos A times cos B plus sine A times sine B. Let's take a look and see what happens if you do sine. So for sine, when you add angles, you get sine A cos B plus sine B cos A. And if you find the difference between two angles, you get sine A cos B minus sine B cos A. Now, you should be able to see a number of similarities between these. So if you are memorizing, as you are memorizing, learning these, one of the tricks to doing that is to look for similarities. So cos is cos cosine sine for both of them, and then it's just a minus and a plus, which are opposite to the plus and the minus of the sum and difference. And sine is sine A cos B, sine B cos A, and it's the same sign. So there's some tricks in there. I'll leave it to you if you want to come up with a memory tool or a mnemonic to learning these, but we do need them for this course, and we do need them for future courses where you'll need trig. So let's put those into memory. And we do have two more. We have the tangent ones as well. Tan A plus B is equal to tan A plus tan B over 1 minus tan A times tan B. And tan A minus B is tan A minus tan B over 1 minus tan A tan B. So again, not super easy to memorize, but there's some definite similarities between those two identities, and essentially as soon as you have one, you'll have memorized both. Let's take a look at a few examples of how we can go about using these identities to prove things and find some other information out about some trigonometric expressions. So let's start off with this one. We want to find the exact value of sine 105 degrees. Well, it turns out sine 105 isn't one of our special triangles, but it is very similar to some of our special triangles. Sine 105 degrees can be thought of as sine 60 plus 45 degrees. Now 60 is a special triangle and 45 is a special triangle, so I can now use my sum of angles identities for sine and rewrite this as sine 60 degrees cosine 45 degrees plus sine 45 degrees cosine of 60 degrees. So this is my A, this is my B, and so I have sine A cos B and sine B cos A. And now I can go about solving these. So I know from special triangles what the 30, 60, 90 and the 45, 45, 90 triangles look like. And so I can simply say, well, sine of 60 degrees would be root 3 over 2, and that's going to multiply by cosine of 45, which is 1 over root 2, and then I'm going to add sine of 45, which is also 1 over root 2, and multiply by cosine of 60, which is 1 over 2. Give myself a little more room here, and I can complete this by combining like terms. So this is root 3 over 2 root 2, and add 1 over 2 root 2, and so I get root 3 plus 1 all over 2 root 2, and rationalizing the denominator gives me root 6 plus root 2 all divided by 2 times 2, which is 4. And I now have the ability to find the exact values of a whole bunch more angles without having to rely on the calculator. Now, you can double check this on the calculator, so you can type in the square root of 6 plus the square root of 2, get an answer, divide it by 4, and see if that's the same as sine 105 degrees. So make sure you're in degrees when you calculate that one, and they should get you the same answer. In fact, that would be my first step if I were doing this on a quiz and I were allowed to use my calculator. Once I had calculated this to the end, I would be going and double checking them, and you should certainly do that through your homework as well, just to get into good habits. Okay, let's take a look at a second one. We can also use the sum and difference identities to help us solve equations. So in this case, I've got sine of some identities, and I'm adding sine of the difference identity is equal to 1, and I want to solve this in radians, so I'm working in radians, and I want the general solution. So again, go ahead and expand this one out, and then expand the second one out, and it still is equal to 1. And when I continue with this work, or just before I continue with this work, I'll hopefully notice that I've got some common terms. I've got a sine pi over 3 times cos x and a minus sine pi over 3 times cos x that cancel each other out, and the other two terms are identical. Combining these together gives 2 sine x cos pi over 3 is equal to 1. And cos pi over 3, so pi over 3 is our 60 degrees, so that's across is root 3, this is 1 and 2. And cosine of pi over 3 is 1 over 2, so 2 times 1 over 2 cancel each other out and just let sine x equal to 1. And I prefer using the graph to find out when sine x is equal to 1, and I can quite quickly see that it's equal to 1 at pi over 2, and so I know when my first solution is, and I know when the other solutions are in terms of radians by knowing the period, and I get my solution to what was quite a complicated equation up in the very first step in black. And let's take a look at how we can use this for proofs. Okay, let's try and prove cos x plus pi over 3 minus cos x minus pi over 3 is equal to negative root 3. So as a proof, I set up my wall and copy both things down. On a quick analysis, it's quite easy to see that the left-hand side is a lot more complicated than the right-hand side, so that's the side I want to work with, and it's in terms of cosine. But let's break apart these sum and difference identities. First one becomes cos cosine sine, with a minus sign in there, and then minus, and I'm just going to be careful when I subtract away a couple of terms. I'll use brackets for this. Again, it's going to be cos cos, and sine sine, and then this was a difference, so this is a sum, and I can see that some things cancel. Cos x times cos pi over 3 and minus cos x cos pi over 3 are the same, and the other two terms combine together to become minus 2 sine x sine pi over 3. And I am allowed to do substitutions in proofs, so sine pi over 3, that's this 60 degree angle, so it's root 3 over 2, so it's minus 2 sine x root 3 over 2. These two things cancel, so I get negative root 3 sine x, which is what I'm supposed to have on this side. Sorry about that, I just miscopied it down, and now I have the exact same thing on both sides. A little mistake. It's all cool. Okay, we're ready for class. We'll see you soon. Bye.